This is a desk from IKEA, and this is a bunch of PDP-1173 parts, and I need to take all of this junk and stuff it all, power supplies, high performance vector processor, PDP-1173 hard drive, floppy drive, all of it into this tiny little cubby right here, which is gonna be a bit of a challenge. That PDP-1173 with vector processor is the control computer and post-processing computer for this Bomem DA3 Fourier transform infrared spectrometer. Now, originally, when Bomem built it, that computer was built into a desk, but that desk has long since been lost, and all I've got are the individual components. And I built those up into a kind of wooden tower thing because I didn't have the DA3 infrared spectrometer at the time, so I kind of made it this little standalone desktop tower that you could haul to shows and whatnot. But Mike, being the absolute legend that he is, let me get my hands on one of these, and so I was able to plug that PDP-11 into the infrared spectrometer and do real deal science. And it was working really well, but then I went and rearranged the entire room. And once we got all the big pieces in place, there wasn't really a good place for that tower computer anymore, and there wasn't even really a good place for the monitor and keyboard that went with it. We only had this tiny little sliver of wall over here, and so I did a little bit of shopping at IKEA, and this desk fit the bill perfectly. It was like incredibly serendipitous. I had absolutely no idea that they would have the perfect thing for me. So here's the plan. The floppy drive and the front panel are going to be the two things that you interact with the most, so we want them to be the most easily accessible. So we're going to put those right up here, right underneath the monitor. And then just below that, we're going to hang the hard drive as well. And then all the way down here on the bottom, we're going to stuff in the power supplies. Now, I don't have the original linear power supplies that would have been shipped with the machine, so instead we're just going to use Meanwells. I've been using those for over a year on it so far with absolutely zero problems, and that's going to work just fine. But also that's a bit of a saving grace because we don't have a whole lot of room in here, and the Meanwells are going to be so much smaller and more compact than the original linears. The PDP-1173 itself is going to kind of sit here on this left side, and then we're going to put a big piece of wood here that's going to kind of split this whole thing into two chambers, and we're going to put the high performance vector processor on this side of it. But that vector processor has a lot of chips on it that get very hot, notably an AM29116, which I think idles at like 60 Celsius. So we need a lot of active cooling on that. So we're gonna punch some holes in this little side piece here, put some big AC 120 volt fans on there that are pulling cool air from your knees and blowing it directly on the vector processor, keeping everything cool. Also, I want this entire thing, with the exception of those AC 120 volt fans, to be able to slide out completely for service. So we're gonna have to kind of build it into a shell that slides perfectly into the opening that we have. In order to even have a hope of making all of this fit, that center shelf has to come out. IKEA stuff is really designed to go together in a very specific order, and I threw away the instructions long ago, so we're just gonna wing it. Fortunately, there was just enough slack once everything was loosened up to get the side panel off and then pull that center shelf out. Then I just gotta slap it all back together, pop the bottom on, and stand the desk back up. Just look at that nice open spot waiting for PDP-11. Let's grab some measurements of the opening. I'll make my marks on some scrap plywood that we had in storage, then run it through the table saw. I'm using two thinner pieces for the top and bottom, and a nice thick piece for the left side vertical. Now, just to double check that I got all my measurements correct, the bottom piece fits perfectly, then the side piece slides right in, and finally the top piece slots in completely on the money. Dang, go me. I almost never get it right on the first cut. I'll drill some pilot holes and then screw the three pieces together. Once I've got the top and bottom pieces secured, I'll carry the whole thing over to the desk and slide it in place, and yup, that's a great start. All right, we've got the basic form done, so let's start building from the bottom up to put some structure into this thing, and we're gonna start with the power supplies. We have two 5-volt 50 amp supplies, one dedicated to the PDP-11, one dedicated to the high performance vector processor. Then we have a 24 volt supply for the floppy, a 12 volt supply for the PDP-11, and a negative 12 volt supply for the 11 and communication to the Bomem DA3. The first step is screwing down the Meanwell power supplies. With those located properly, I now want to get 3 little cooling fans in place. I'll bend up some scrap metal to work as a mounting bracket, then I'll screw them into place in front of the power supplies. Once everything has been secured, the tedious yet surprisingly cathartic process of wiring begins. I'm starting with just the AC wiring for now, and once I'm happy that's going to work, I need to slice up a top for the power supply. Since I'm using a thinner piece for this top panel, I'm going to have to mount it a little different than normal. I'll punch 2 holes in one side, then bolt on little 90-degree angle bracket. With that power supply top panel mounted, it's time to figure out the main vertical that will sit in the center and everything will mount to. Its position will be dictated by the width of the floppy drive. And speaking of which, once that vertical piece is in place, I'll mount the floppy with some little angle brackets on the front and a little clamp in the back. This was surprisingly rigid. And that now allowed me to figure out how to mount the hard drive. I'm reusing a lot of pieces from the previous case. This side piece prevents the drive from sliding further backwards, and this little L bracket will prevent the drive from sliding forwards. Then I'll just slide the whole hard drive shelf into place under the floppy and screw it down. And I'm pretty happy with how this is coming together, which means it's time to take the whole thing apart again so I can then sand it all nice and smooth. The hardest part of this sanding job was the side panel that had some thick paint on it from decades ago. Still, I got it pretty well stripped back, and then I pulled out some nice dark stain and lathered it on. A little bit of stain can make some scrap plywood look really, really good. I am quite happy with how literally this was junk wood that was out in storage has turned out. This is awesome. So I think we're ready to start final assembly. I mean, it's mostly dry, it's a little bit sticky, but well, we're just gonna keep pushing on. The next step I think is to get the front panel in. I'm gonna mount that, I think, right about there. And then underneath that, we're gonna put the vector processor. On the other side of here, we're gonna put the PDP-11 73 itself. And once we get all the heavy hitters installed, then we'll run power to everything. Then we'll start getting the I/O installed and finally the ribbon cables. And hopefully by the end of today, maybe midday tomorrow, this thing will be ready for a first power up, which will be pretty exciting. I need to make a little mounting bracket for the front panel, so I'll grab some scrap steel plate and put a nice 90-degree bend in it. Then I'll punch 4 holes in the corners where the front panel will mount. I'll then slide some vacuum hose over the bolts to act as an insulating spacer so we don't get any weird shorts. Then once it's all bolted together, I'll mount it to the main case with 2 screws. Next, I want to get the cooling fans for the PDP-11 card cage in place, but I need to spacer them up enough to draw in fresh, cool air. To do that, I'm going to use little chunks of brass tubing. There's probably a more graceful way to mount these to the bottom, but big 2¼ inch screws seem to get the job done with no problems. Next, I'll punch 3 holes through the center vertical piece and then bolt the card cage to it. With the PDP-11 mounted, let's get that vector processor mounted on the opposite side of that center vertical piece. After drilling some pilot holes, I'll thread in little standoffs directly into the wood. Then the vector processor itself just bolts directly into place. Now it's time to start working on power supply DC wiring. So I'll lay it on its side and pull the bottom off to access the power supply. And if it looks like I know what I'm doing, don't worry. I actually ended up pulling the bottom off and redoing DC wiring 3 more times as the build progressed. It wasn't necessarily because I got something wrong, but rather because as I got further along, I could see better ways to do things, so I'd pull it apart and rewire. At any rate, I got most of the DC wiring squared away with the exception of I/O. Now, normally I/O doesn't need external DC power, but the opto isolator board for the spectrometer needs +12, +5, and -12. So let's get that I/O squared away. I'll reuse the aluminum mounting panel for the opto isolator board, but I need to make a new panel for the CRT keyboard and serial connections. And I really hemmed and hawed about the best way to do this because cutting the weird trapezoidal shapes for D-shell connectors is a pain. Ultimately, this was my solution, which I think was pretty clever because it only took drilling a couple of holes. There are small holes to mount the connectors to, and then the big holes are for the cabling to pass through. Once I have the aluminum plate mounted to the opto isolator mounting plate, I'll bolt in a bunch of standoffs for the D-shell connectors. Then the ribbon cable for the connector passes through the big hole in the middle, and the D-shell connector mounts on the standoffs, only I'm just now realizing that my standoffs are too short. So the whole thing comes apart again so I can bolt on taller standoffs. And with these taller standoffs in place, the D-shell connectors fit perfectly. Then I just got to bolt them down into place using little screws, and man, that turned out awesome. A little bit steampunk, but also extremely usable and spacered out perfectly. All right, I think I've got all the power finally fully run, so I want to give it a test, but I don't want to blow anything up in case I've got something wrong. So I've got everything disconnected. All of the cards are out of the card cage. Both of the power cables for the drives are unplugged. The I/O power is unplugged. The HPVP is unplugged. So we're not going to hurt anything. The only thing that has power going to it is the backplane, which is fully passive, and well, I don't think we can damage that in any way. So let's flip the power switch on and see how it goes. That's good. I've heard fans kick on. I can feel some air coming out the backside here, and I can feel air coming up through the backplane. That is good. Let's check the backplane voltages. We should have plus 5 volt and plus 12 volts on there. Yeah, there's 5, and then this should be plus 12. Yeah, all right, that's a good start. These are the I/O connectors right over here, and we should have plus 5 volts on that one. And then we should have minus 12 volts, plus 12 volts, and then this one on the far end is a return. So all of our I/O connectors are correct. And then up here on the top is the drive power. We should have 5 volts, or that one's 12 volts. I guess I was looking at it from the wrong direction, but that one is 12 volts. Then we should have 5 volts on that one. And then over here we should have 24 volts. Yeah, 24 volts and then 5 volts. Okay, that's all power in the correct places for the drives. And then over here, we've got the high performance vector processor power. This should be 5 volts. Yep, there we go. 5.085, that is looking good. And then the last one is coming from this little transformer right here, which is gonna be putting out a 24 volt AC signal for our line time clock. So I need to actually change this over to AC. Got that on this little red wire right here. And if I plug into that, 29 volts. It's a little high, but if I remember from the schematic, there's a huge resistor divider and a clamping diode, so that's gonna be totally fine. With the power in all the right places, let's get the data into all the right places. But these big flat ribbon cables are an absolute nightmare to route properly. The vector processor uses 3 50-pin ribbon cables, then the floppy uses yet another 50-pin ribbon cable, and then the hard drive uses a 34-pin and 20-pin ribbon cable. My management solution is to use little pieces of plexiglass to hold the cables flat against the side. It's good enough, though not as tidy as I would have hoped. Still, I think it's time to give this thing a test, which means we need some vector processor cooling. Then I'll pop the monitor down on the table and bring the special Bomem keyboard over as well. Finally plug all of that into the new I/O panel. All right, it's all together. My cable management is not the best, but I think it'll work. Let's see what all we broke. Oh man, I hope nothing broke. I've got it in halt, so if it powers up, we should see a memory address up here and we should be in ODT. So fingers crossed, let's go. Yeah, oh man, okay. Well, that's the first major hurdle overcome. Yeah, my hard drive is spinning up. Let's come out of halt and I will reset it here. And it's gonna say SRQ-D11 boot. Hopefully our hard drive is healthy. I would have expected the light to go off by now, but it's still on. But it says booting from DU0, so it at least sees the hard drive. Yeah, the fact that this light is just on and always on is not good. It's always on the disk controller down here as well. But we should have booted into RSX11 by now. So yeah, something's unhealthy. But I do have the majority of it together, at least. And there's a problem for sure. This is the hard drive controller card here, and you can see there's a little arrow here indicating pin 1, and the red stripe on my cable is on the bottom, and that's for both of these. So yeah, that's definitely not gonna work right. I need to flip those around. Well, that just made my ribbon cable management through here worse, so hooray. But hopefully this will fix it. Let's go ahead and flip the power switch. Hard drive is spinning up. The light did go off this time, that's good news. So I'll flip it out of halt and we'll go ahead and hit reset. It's going to say SRQ D11 boot version 4.5. As soon as the hard drive is fully up to speed and ready to read, the this controller is going to start hitting it, and we should see this light flashing. Yeah, there it goes. That's kicking on, and then hopefully we'll see RSX11 or something coming up here. Yes. Oh, man. RSX11M version 4.1, 1024K mapped. That is 1024 kilo words. One word is 16 bits, so that's a full 2 megs of memory. If we had a bigger RAM card, we could expand it out to the full 4 megs, but we don't particularly need it. So I just hit enter on that. That means that the keyboard's working, the monitor's working, our graphics card is working. We'll see, it's going to initialize the graphics card here shortly, and we'll see the screen blink here. And when it does that, it's going to change refresh rates, actually. Yeah, there it goes. So that was the Matrox Graphics Load A MG, that thing right there. So now probably this camera is not synced up to it very well anymore, but this is good news. It means that we're pretty much all the way in. So let's go hello, Usagi. Password is Usagi. Good afternoon. And if I hit menu here, this should boot us into the Bomem software. So our full color graphics are working perfectly. We're fully into the Bomem software. If I do a status, it's going to load a bunch of microcode into the high performance vector processor. And the fact that it hasn't errored out already is good news. That means that there is communication going on between the two, and we should get our status screen here shortly. Yeah, there we go. Now, all of our status is nothing because the spectrometer is on the other side of the room and not plugged in, but that's good. That means that communication between the PDP-11 and the vector processor here is working. The last thing we need to do is make sure the vector processor doesn't overheat when it's in situ in the desk. To do that, I'm going to mount two 120 volt AC cooling fans into the actual desk. I'll mock them up, measure them out, lay down some markings, then drill holes through the 4 corners. Thankfully, the jigsaw had the perfect stroke to cut all the way through without snagging on the bottom piece. And since IKEA desks are really just 2 very thin pieces of wood glued to an internal cardboard structure, the jigsaw cut through this thing like butter. Dropping the big cooling fans into place, it was totally serendipitous that the fans were exactly the same width as the table itself. Since the wood is so thin, it's hard to mount anything to it, so I doubled up on the mounting brackets with 4 on each side to give these fans the best chance of staying in place. After confirming that they do indeed spin up and move a good bit of air, let's slide the whole thing into place, and man alive, that is absolutely amazing. The fit is perfect, and all the little mistakes that bother me are completely invisible when it's in place. Well, I'm extremely happy with how that turned out. So now I have a PDP-1173 built into a desk, hooked up to a Fourier transform infrared spectrometer. Let's take it for a test drive. I'll do a shift 2 to exit out of the status screen here, and we'll start with a phase, PHAS here. And it's going to bring up a bunch of options, and we want to have source 2, filter 2, detector 2, but we do want to go down and change our aperture size all the way up to 5 millimeters here. We're going to take 10 scans. I'm just going to go ahead and hit return on that and let it go. And the mirror should start moving over here. Yeah, there goes the mirror. Looks like we're getting about 40 to 50% peak percent gain. That really needs to come up. We're attenuating through a little piece of paper because I haven't reduced the brightness of the light on that. That's one of the next things that we got to do. There we go, computing FFT. So that's going to be our vector processor doing real deal work there. As soon as that finishes, we'll hop over to display. Yep, there we go, ready. Now this is going to create a spectrum which we can view on here, but I also want to take a look at the actual phase itself. So I'm going to toggle down and do an SY0 colon QZ2 QU2.phs. And if I go ahead and hit return on that, it's going to find both of those files and it's going to display them on the screen simultaneously. How cool is that? A PDP-11 with full color graphics. So there we have it, real deal PDP-1173 built into an IKEA desk. This came out just perfect. It fits the needs perfectly. Like it's such a narrow space, and yet we were able to put that much firepower into this space, get it hooked up to the infrared spectrometer here, and as you can see, start doing real deal measurements on it. This is incredibly exciting, and this came out looking absolutely beautiful. I have some pretty exciting projects planned for this infrared spectrometer coming up, notably one with capacitors and the goo inside of them. I think it's going to be a fascinating look at how capacitor electrolyte has changed throughout the decades, and that's something that this machine can do really well. But I got to get better at using it, which means, Mike, there's going to be a lot more phone calls coming as I figure out how to actually use this thing to figure out the molecular compositions of things. So I'm incredibly excited about that. We have a lot more projects coming. Obviously, we need to get this thing down into vacuum. I need to get water cooling into it. We need to try and take it into the infrared. And someday I want to try the far infrared with one of the liquid nitrogen cooled detectors. I think that's going to be really exciting too. So I want to thank you all so much for hanging out with me today, and I hope to see you in the next one.